Dear students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now we will be learning about some practical applications of the sequences and series that we have learned so far. Okay, and our today's topic is the growth and decay. This is a real life application of geometric sequences or geometric progression. There is an initial condition corresponding to the time 0, the starting time. That is referred to as the time 0. Okay. This becomes our first term of the sequence, which is U0. Usually we take the first term as U1. We have learned to take the first term as U1. So far we have taken that as the first term, U1. But since this U0 is corresponding to the time, starting time or time 0, therefore we are using this subscript of 0. And we are taking U0 to be our first term instead of U1. Okay. And this process may be applied for any population growth model. Population growth model, the animals, the human beings, the population may be increasing. For endangered species, it may be decreasing. For monetary model, suppose someone is working in a firm or in a company where the salary increases every year by a fixed rate. So it is a very good company. I should be saying that the salary is increasing every year at a fixed rate, and we all want to work in those companies. So that will be a monetary growth model. Obviously, we want to receive more and more money. And or radioactive decay model. Radioactive substances obviously go on decaying and they have their half-life. So it is a case of a decay model. The population growth can be a growth model or a decay model. The monetary model also, it can be, if it is a case of receiving money, we would definitely be wanting to have it as a growth model. And the radioactive particle, they are an example of a decay model. Okay. Now, if U0 is the initial amount that we have seen, R is equal to the growth multiplier for each period of time or each time period. N is equal to the number of time periods and Un is the amount after n time periods. Then the equation will be taking all these terms together. It will be Un is equal to U0 times R to the power of n. We are familiar with this type of a relation. Un is equal to U1 times R to the power of n minus 1. Okay. Where U1 is the first term, R is the common ratio, n is the number of years, or actually it is the term number, not number of years, but it is the term number. Un is the nth term. So this is the general term formula for any geometric series. Now, when we come to the real life application and we come to the growth and decay model, this formula gets changed, gets modified to this form. Over here, we are having Un equal to U0 times R to the power of n. Okay. Now that we have come to know about the formula, let us solve few questions based on this growth and decay model. Okay. The first question says, a herd of 32 deer is to be left unchecked in a new sanctuary, it is estimated the size of the herd will increase each year by 18%. And the first step asks us to get the estimate the size of the herd after 5 years. So let's start with our answer. First subpart A. We are having 32 deer in the herd. So U0, this is the size of the herd at time 0, the starting time. So U0 equal to 32. And after 5 years, so N is equal to 5. And we have to get the value of UN. In order to get the value of UN, we need the value of R. Now, what is the value of R? Do not write that to be equal to 18% or 0.18. It is wrong. Let us see what is the multiplier. Okay. So, let us find the value of U1. U1 is the herd size after 1 year. So, U1 will be equal to 32 plus 18% increase. That is 18 over 100 times 32, right? So, this is equal to 32 and 1 plus 18 over 100 is 0.18. So, this is equal to 32 times 1.18. Okay. So, this is the value of U1. That is the herd size after 1 year. Let us find the herd size after 2 years. So, for 2 years, the initial herd size is this one. So, it is 32 times 1.18 plus 18%, that is 0.18 times 32 times 1.18. Okay. So, this should be equal to, I can take 32 into 1.18 common, and we have 1 plus 0.18. This is also equal to 1.18. So, we have U2 equal to 32 times 1.18 whole square. Now, you can find the justification of having this formula. UN is equal to U0 times R to the power of N. When it is U2, N is equal to 2. So, R value is this. 32 is U0. R value is this. This is getting raised to the power of 2. Because N value is equal to 2. So, R is not equal to 0.18. It is equal to 1.18. When you are having something increasing by a fixed percentage every year, you first of all convert that percentage to a decimal number and add that decimal number to 1 to get the multiplier or the R. Okay. That will be the R value. Whatever is the increase rate given in percentage, you convert that to a decimal number, and that decimal equivalent should be added to 1 to get the value of R. Okay. So, R value is equal to 1.18 in our case, in this case. Okay. So, therefore, UN should be equal to, U0 is equal to 32 times 1.18 to the power of 5. What is the value? 32 times 1.18 to the power of 5. 73.208. So they have asked us to estimate the herd size. So we can give them this value of 73. It is almost equal to 73. So the herd size will be approximately equal to 73. There will be 73 deer in the herds and 73 deer approximately. So this is our answer. After 5 years, the herd size will be approximately equal to 70. So, subpart B. How long will it take for the herd size to reach 5,000? Okay. So, the subpart B. How long means we have to find the value of n. U0 is equal to 32. We do not know n. So, n is equal to what? Question mark. R is the same. It is 1.18 and un is equal to 5,000. Okay. So, let me just draw this line. Okay. So, now we have to get the value of n. Therefore, we write 5,000 is equal to 32 times 1.18 to the power of n. Okay. Or we can write 1.18 to the power of n is equal to 5,000 over 32. Okay. Which should be equal to what? Let us see. 5,000 divided by 32. Sorry. So let me 5,000 divided by 32. 156.25. Okay. So this is 156.25. Now we can take the log of both the sides and taking the base as 1.18 and it is 1.18. So this part will be equal to 1. This is equal to log of base 1.18 and the argument is 156.25. Okay. So what is this answer equal to? Okay. It should be log and base will be 1.18 and this one will be 156.25. So the value is 30.519. So roughly equal to 30.5. Okay. So this is roughly equal to 30.5 years. Okay. So our answer is 30.5 years. This is our answer to the subpart B. And let me show you another way of solving this equation. This way is sufficient to get the n value, but I have seen many students struggle with the TI-Nspire calculator. So let me show you another way of solving an equation. Okay. So it is 32 times 1.18 to the power of n equal to 5,000. the method that I'll be showing you is the numerical solve or the NSolve method. Okay, so it is 32 times 1.18 to the power of, I'm taking x, okay, and is equal to 5,000, and I have to declare the variable. Okay, so the variable taken is x, and I come to this part. Fine. So let the calculator give me the answer, and you see they have given me the exact same answer that they had given me when I was using the logarithm. Okay, it is 30.519738, roughly equal to 30.5. I am not writing the NSolve thing, I am just showing you that you can get the answer by this method as well. Okay, so we have solved the first question. Let us go to the next question or the second question of this session. Okay, each year a physicist measures the remaining radioactivity in a sample. She finds that it reduces by 18%. This is a case of reduction. In our previous question, it was a case of increase, but this time it is reducing by 18% each year. If there was 1.52 grams of the radioactive sample left after 4 years, find the initial quantity of the radioactive material. Okay, so let us start with our answer. Initial quantity has to be found out. So initial quantity is what? It is U0. We do not know the value of U0. We have to find the value of U0. What do we know? We know the value of UN. UN is equal to 1.52. And what is N? N is equal to 4. Now let us come to the value of R. Here they are saying that it is getting reduced by 18% every year. So what will be the value of R? It will be, suppose U0 is we have taken U0 as the initial quantity. So what will be U1? U1 will be equal to U0 minus 18% is 0.18 times U0. Okay. So this is equal to U0 and 1 minus 0.18, which is equal to U0 times 0.82. Okay. Similarly, if we want to get the value of U2 after 2 years, this becomes our starting value. So it is U0 times 0.82 minus 0.18 times U0 times 0.82. Okay. So this gives us, if I take U0 times 0.82 common, again I get 1 minus 0.18. This will be equal to 0.82 and I will be getting U0 times 0.82 whole square. Okay. So now we can understand that the R value is equal to 0.82. Okay. So this is our calculation. The rough part, R value is equal to 0.82. This you have to understand. Do not write the R value as 0.18. You will be having an incorrect answer. Okay. Always remember, if the something is getting reduced by some percentage every year, you have to first of all convert that percentage to its equivalent decimal number and subtract that decimal number from 1 to get the value of R, if it is a case of reduction. But if it is increasing by some percentage every year, same thing, first of all, you convert the percentage to its corresponding decimal number and add that decimal number to 1 to get the value of R. In case of increase, you add the decimal number to 1 to get the value of R. In case of reduction, decreasing, you subtract the decimal number from 1 to get the value of R. Okay? Now, we can form the equation. It is 1.52, Un is equal to 1.52 equal to U0 times 0.82 to the power of 4. Okay? So, we can find the value of U0 directly using the NSolve. Let us go for that value. If you don't want to use that NSolve, I can give you the equivalent or the alternate method of getting the value of U0. It will be 1.52 divided by 0.82 to the power of 4. Okay. So, okay, fine. Let me show you what do we get by this method, and then I'll be going for the NSolve method. Okay. So, it is 1.52 divided by 0.82 to the power of 4. 1.52 divided by 0.82 to the power of 4. It is equal to 3.3619. So, we can take it to be equal to 3.36. Okay. And now, let us use the NSolve method. Let us see what is the value that we are getting using the NSolve method. And what was the equation? It was U0, let me take that to be equal to X. X times 1.18 to the power of 4 is equal to 1.52. And now we have to declare the variable. It is X, so I have declared that variable and I try to get the value. Sorry, what did I do? Oh, sorry, very sorry. I have taken the 1.18 from the previous question. Let us get the value of the N. NSolve this time. I have to do it correctly. So, it will be 0.82 to the power of 4, and then I come down equal to 1.52, then comma, and I declare the variable X. And I come over here, and what is the value? Now you see I am getting exactly the same figure that I have got before using the 1.52 divided by 0.82 to the power of 4. It is 3.3619262. This is exactly the same value I am getting over here. Okay. So I am taking the answer to be roughly equal to 3.36. So, it is roughly equal to 3.36 grams. Okay. So, it is roughly equal to 3.36 grams. This is our answer for this question. So, students, this brings us to the end of this session. this session on the growth and decay model. We will be having few more sessions on practical applications of the sequences and series. So, we will be meeting very soon in our next video session. Thank you for watching this video till the end. Please give this video a like if you find this video helpful. Please subscribe to my YouTube channel. This will be motivating me to make more math videos which may be helping you in your math classes. And please do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. So bye for now.